Two galaxy clusters slam into each other. The impact should be simple. If most of the mass is tied to the matter we can see, then everything important should stay together as the collision unfolds. Instead, the collision begins pulling the clusters apart in different ways. A vast cloud of hot gas crashes head-on and slows down. It bunches up near the center, trapped by the impact. But the stars behave differently. They keep moving. They pass through the collision and continue on their way. Now the clusters no longer look like single objects. Their visible components have separated. What was once moving together is moving apart. That creates a problem. If mass follows visible matter, then the bulk of the mass should remain where the most obvious material ended up. The collision seems to offer a clear answer, but the separation refuses to stay simple. The gas is in one place, the stars are somewhere else. And suddenly the assumption that visible matter tells the whole story becomes harder to defend. The collision is over. The missing mass is not. The collision leaves behind a simple expectation. Find where the matter ended up, and the gravity should be there too. So astronomers look for another clue. They examine how the collision bends light passing through it. Background galaxies appear slightly stretched and distorted, as if an invisible hand is warping the space between them and Earth. The pattern of that distortion allows the mass itself to be mapped. The result should have settled the problem. Instead, it deepens it. The strongest gravitational signal does not gather around the slowed gas. It appears farther ahead, in the regions that kept moving through the collision. Now two maps sit on top of each other and refuse to match. One map shows where most of the visible matter is concentrated. The other shows where most of the mass appears to be, and they are not the same place. That immediately weakens the easiest escape route. A measurement error can explain a strange result once. It becomes harder to defend when an entirely different method points to the same separation. The gas remains behind. The gravity appears ahead. The collision is no longer just rearranging matter. It is exposing a mismatch between what can be seen and what seems to be producing the gravitational pull. At that point, another possibility begins to linger. Maybe the missing mass is not the only thing being misunderstood. Maybe gravity itself is behaving in a way nobody expected. The idea that unseen matter fills the universe is not the only possible answer. Another path begins to emerge. Instead of adding something invisible, some researchers ask a different question. What if the missing mass is not missing at all? What if gravity itself behaves differently under certain conditions? That possibility immediately changes the picture. The strange motions seen in galaxies no longer require enormous amounts of unseen material. Stars circling far from galactic centers can continue moving in ways that previously seemed impossible. Observations that once appeared to demand extra mass begin matching predictions through a different approach. For the first time, a competing explanation starts doing real work. The missing matter problem no longer points in only one direction. A universe filled with invisible mass is still possible. But a universe governed by different gravitational behavior now appears possible too. That changes the stakes. If these alternative ideas can reproduce some of the very observations that helped create the missing mass problem, then the case for invisible matter is no longer standing alone. The contradiction remains, the strange motions remain, but the need for unseen matter suddenly feels less certain. And if gravity can explain those earlier anomalies, an obvious question follows. Can it explain the collision as well? The alternative explanation survives right up until it collides with the bullet cluster itself. The collision has already separated the pieces. The hot gas slammed together and slowed down. The galaxies kept moving. The system no longer looks like a single object. It looks like different components heading in different directions. That separation creates a test. If modified gravity is responsible for the strange observations, then the gravitational signal should remain tied to the visible matter that stayed behind. The prediction has somewhere specific to stand. Then the measurements arrive. The map created from gravitational lensing does not concentrate around the slowed gas. Instead, the strongest gravitational signal appears where the galaxies continued moving after the collision. The effect follows the galaxies. The visible matter does not. Now the competing explanation faces a direct problem. The prediction and the observation are no longer traveling together. The collision has physically pulled them apart. The gas remains in one location. The gravity gathers somewhere else. At that point, the possibility that gravity alone is creating the illusion begins to lose ground. Not because the idea sounded unreasonable, because the collision produced a visible arrangement that the idea could not successfully track. The bullet cluster turns the argument into something physical. Something appears to have moved through the collision alongside the galaxies. Something appears to be contributing mass where very little visible matter remains. The invisible component is no longer just a convenient explanation. It begins to look like a necessary one. And if that unseen mass is real here, inside a collision large enough to separate an entire cluster, the implications do not stop with this single event. The bullet cluster does not remain an isolated curiosity. The same invisible mass that appears necessary in the collision begins appearing in other places as well. Galaxies continue holding together when their visible content suggests they should not. Large structures stretch across the universe in patterns that require more gravitational influence than visible matter seems able to provide. Again and again, different observations point in the same direction. The missing gravity is no longer appearing in one place. It keeps showing up in systems that have nothing else in common. The collision becomes part of a much larger picture. Not because it introduced a new idea, because it turned an idea into something physical. The bullet cluster took an abstract explanation and forced it into a visible event. The galaxies moved one way, the gas moved another. The gravitational mass followed neither expectation nor convenience. It followed the same invisible component that appears wherever the universe demands more gravity than visible matter can provide. That changes the meaning of the collision. It is no longer just a strange collision between galaxy clusters. It becomes evidence that much of the universe's matter may never have been visible in the first place. The question is no longer whether the missing mass exists. The collision made that position far harder to defend. The result is a fundamental shift in how the universe itself is counted. Not by counting only what shines, but by accounting for what its gravity continues to reveal. The collision did not reveal exactly what the missing mass is. It changed something more fundamental. It became far harder to pretend the mass was not there.